Normal distributions in the bell curve. Okay, a couple things that we have to talk about in this lesson. First of all, what's a normal distribution? A normal distribution is a situation where the mean, median, and mode are all the same value, and when plotted, the data follows a normal curve. So that's a pretty unique kind of situation where the mean, median, and mode are all the same value. Okay? What's going to happen here is you're going to know that this kind of situation applies because, well, you're going to be told. Okay, it's going to say in a normal distribution, or that data is normally distributed. All right, if that is the case, then you're going to use like this curve here. All right, this picture here, this graph we have is a standard normal curve with standard deviation on it. This is the one you get for the Regents exam. Okay, what it has here is some information that's presented. All right, what I have is these things down here: this 0, this 0.5, this 1, this negative 0.5, this negative 1. That is the number of standard deviations. Okay, so if I have like one standard deviation above the mean, that's talking about like right here. This 0, sometimes you'll see, and if you look at the above my smartboard in my classroom, I actually have X bar written there, okay? And then over here at 1, instead of having 1 there, I have X bar plus sigma, which is like one standard deviation above. And then where this would be 2, I have X bar plus 2 sigma, right? And so on like that. And all the way out to this last one here, which is X bar plus 3 sigma. And likewise down this way, this one's X bar minus sigma, and this one is X bar minus 2 sigma, and this one is X bar minus 3 sigma. So when it's talking about being like one standard deviation above the mean, it's talking about being at that place in the bell curve. All right, and we have the percents inside the bell curve. What these represent is how much data you can expect to find in each one of those ranges. So if I asked you, what such and such data is distributed normally, what percent of the data it lies between the mean and one standard deviation above the mean. And what happens there is, well, I've got these two things here, right? 19.1 plus 50, which when you add those together, that's like 34.1%, okay? So you could say it's 34.1%, and in a lot of instances, this is rounded to 34%, all right? One of the things they talk a lot about is the percent of data in a normal distribution that is within one standard deviation of the mean. So that's from here, one standard deviation above, to one standard deviation below, all right? And if you take and you just add all these percents from this graph here, you're actually going to get 68.2, but that is always rounded, that's frequently rounded to 68%, okay? So in a normal distribution, 68% of the data is within one standard deviation of the mean. Okay, and within two standard deviations of the mean, all right, this is the other one here, like if we go out here, here to here, right, and we go 2 standard deviations below and 2 standard deviations above, all right, the percent of data that lies in there is actually, if you add all of these together, you can figure it out, or you can take these ones out here and subtract it, like 1.7 plus 0.1 is 1.8, that's going to be like 2.4, right? 2.3 on either side, right? Okay, so that is how you can find out the percent that is within 2 standard deviations of the mean. All right, and that is always kind of rounded to 95%. Okay, so 95% of the data is within 2 standard deviations of the mean, and 68% is within 1 standard deviation. All right, and then out here, all the way out here, right at 3, that's like 99.7% of the data. Let's say that's like 99.7 of the data is within 3 standard deviations of the mean. Okay, so what I want to do is draw and label a bell curve to fit data that has a mean of 56 and a standard deviation of 3. So when I do this, I'm going to just sketch a normal bell curve. And it's not art class, just do the best you can and make it go up like this. And then right here in the middle where this curve is at its highest, that's where the mean goes. Well, this time my mean is 56. So I'm going to put 56 there, okay? All right, and then I'm going to put dotted lines for the, I'm going to put like solid lines for the standard deviations. 1, 2, 3, 1, 2, 3, okay, and then in between those I'll put little dotted lines to represent the half standard deviations. I like to add the halves because the graph that you're given on the Regents exam has the half standard deviations on it, okay? But I'm not going to necessarily label them right away. If I have a standard deviation of 3 and 56 is my mean, one standard deviation above, right? So one standard deviation above the mean here is going to be 56 plus 3, which is then 59. And then I'm going to add 3 again to get to the next one. So 59 and 3 is 62, right? And then 62 and 3 is 65. And it goes the same way the other way. Like one standard deviation below the mean, all right, is 56 minus 3, or 53, right? And then this one is 50, and this one's 47. Okay, so what percent of the data in this set would we expect to be between 53 and 59? Well, that's going to be 68%. That's within one standard deviation of the mean. What percent of the data is between 50 and 62? Well, that's going to be about 95. Okay. Now, if it asks for other numbers, you have to kind of like figure out what they are, all right? The Regents is always going to give it to you in like halves. So it's either going to be 1 standard deviation, 2 standard deviations, 2.5, something like that. So if it's 3 for each one of these, then I can do halfway between 56 and 59, all right, is going to be 57.5, right? And then here I have 60.5, and then I have 63.5. And so on, all right? And you could fill in all the halves if you wanted, all right? Whatever ones you're going to need, I would fill in, okay? This here, this is calculator stuff, and I'm going to skip this for now, all right? And if there's time in class, I mean, I'll show it to you. It's not really necessary at all to be able to use the calculator for this, okay? It's just kind of an interesting thing that you can do with your TI calculators. All right, so we're going to go kind of right to example number 2. The test grades for a Math B exam were found to have a mean of 88 with a standard deviation of 3 points. What percent of students scored between 85 and 91? Now, on the Regents, you're going to get one normal curve question. And I don't know if you've noticed, but on the formula sheet that I've been giving you with your tests this year, down at the bottom, it has this picture, okay? On the Regents exam, you would kind of flip to this point, right, and find this. You can either draw your own normal curve, or you can kind of add information to the one that's given. So I'm just going to add information to this one that's given. All right, so it says a mean of 88. So that's going to go right here in the middle where the mean goes. All right, 0 standard deviations away from the mean is 88. And it has a standard deviation of 3 points. So I'm going to then fill in the rest of these 1, 2, 3, -1, -2, -3 by going up 3 or down 3 each time. 88 plus 3 is 91. 91 plus 3 is 94. 94 plus 3 is 97. Okay? And those are here, 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 and here. All right? And then subtracting 3, here I've got 85. And then I've got 82, and then I subtract 3 again, and I have 79. Okay. Now, they want to know what percent of students scored between 85 and 91. Okay, between 85 and 91. And those are right on my curve. You can see them. They're just right there. Okay, I'm going to kind of show you between 85 and 91. And all I need to do there is add up those percents. All right, so it's going to be 15 plus 19.1 plus 19.1 plus 15, and that gives me 68.2%, and another acceptable answer is 68% because, like I said, that's frequently rounded to 68%. That's within one standard deviation of the mean. What percent of students scored between 79.5 and 88? Okay, 79.5 and 88. And you know what I'm going to do? I'm going to just change that 79.5, all right? Because the Regents is going to give you something that's either a full standard deviation away from the mean or a half, okay? So 79.5, I'm going to change that number, and I'm going to change that to 80.5, all right? We're going to change that to 80.5. And if there's time in class tomorrow, I'll show you how you can do it with exactly 79.5 in the calculator, all right? Or you can read through the directions and probably do it yourself, all right? So I find 80.5 here on the graph, and that's right here, 80.5. There we go. All right, now I'm going from 80.5, which I just kind of showed you right here, all the way up to 88. So I need to add those percents. 1.7 plus 4.4 plus 9.2 plus 15 plus 19.1. Okay, and then you add those up, and then you'll find your answer. Okay, so 1.7 plus 4.4 plus 9.2 plus 15 plus 19.1. That gives you 49.4%. There is a shortcut to that. Basically, 50% of the data, 50% of the data is from the mean this way, right? All the way this way. That is 50%. So basically, if you're right here, you could take your 0.1 plus 0.5, that's like 0.6%. Okay, when you combine those two and subtract it from 50, and you'll see you'll get 49.5. All right, 49.5 should be 49.4. Okay. What percent scored greater than 94? So greater than 94, I'm just going to take and add up the percents that are to the right of 94. Anything greater than 94 are these guys over here. Okay, so that's going to be 1.7 plus 0.5 plus 0.1. All right, and you're going to add those together. 0.6 and 1.7 is going to be 2.3%. Right. What percentile would a student be in if she scored a 97? Okay, so a 97, that goes up to 99.9, all right? So that is in the 99th percentile, all right? Because 99% of the data is before it, okay? If 80 students took the exam, how many would you expect to score between 82 and 94? All right, so now I need to find out the percent that are going to be between 82 and 94. Okay, that's the first step in that. All right, between 82 and 94. So between 82 and 94, we add up all those percents in there. Okay, well, that's within 2 standard deviations of the mean. That's 95% of the students. All right, so it's 0.95 of how many kids that took the exam, all right? So it's 95% of 80 kids, all right? So you got 0.95 times 80. And 76. All right, I'd expect 76 students. Right, which means 4 scored outside that number, all right? What is the score you need to be in the 93rd percentile? We'll get to that tomorrow. What is the probability a student chosen random would score greater than 65? We'll talk about that one in class tomorrow too. Okay, so we've got a couple things to finish up, and like I said, I'm going to show you how to use the calculator to do these as well. Okay, thank you. Good luck.